Hey folks, how we doing? Yeah, cool, awesome. All right. My name is James. I have been doing PHP since around 2002, so not quite as long as Sarah. But I have been programming since before that on various things. I'm open source contributor when I have time, whatever that means. I'm available to hire through Roave usually. Quite busy at the moment, so maybe not right now. But we do have plenty of freelancers available to hire to help on all sorts of projects, like making quality stuff, upgrading legacy, and all that kind of stuff. Anyway, you can find me on Blue Sky and Mastodon, and of course on the Roave Discord server. Some of you may be on it already. You can chat with the Roave team. We've got a bit of a community growing there as well. We've got friends and gaming, open source stuff, home automation, all kinds of stuff. And of course, you get to chat with us and ask us silly questions or sensible questions. So feel free to join the Roave Discord. It's discord.gg/Roave. And we also organize some impromptu events and meals out and so on to socialize at conferences like this, perhaps. Join and find out more. So I'm currently doing some work for the PHP Foundation. You probably were all at the keynote from Roman anyway, so you know what it is. I don't need to explain that. But one of the big supporters of PHP Foundation is the Sovereign Tech Agency. Roman mentioned that this was one of the projects they were particularly interested in. The Sovereign Tech Agency is funded by the German government, and their goal is to promote and improve open source ecosystem, make sure it's sustainable and it has a future, because so many things depend on this stuff. And obviously they have a vested interest in that. So one of the projects they're supporting is Pi. So a big thanks to the Sovereign Tech Agency and, of course, all the supporters of PHP Foundation. And on a personal note, I think more governments should be following the example that they're doing in Germany. So, actually investing in this stuff rather than just using it and like that. Yes. So, what is Pi? It's a little emoji. So Pi is the PHP installer for extensions. We took some slight liberties with the acronym, but it's cool, it's nice. And of course, there's an emoji available, which means I pepper it around everywhere now. It's a new tool I'm working on for the PHP Foundation, and it is used, as the name might suggest, to install PHP extensions. And we know how to make PHP extensions now, thanks to Sarah's talk just now. If you're watching on the live stream and didn't catch Sarah's talk, well, you can watch it back soon on YouTube, I think it is. They put the videos on. So what's the goals of Pi, right? What are we trying to do? Well, before we can understand why we're trying to do this, we need to look into a bit of history. So first up, there was PECL, the PHP Extension and Application Repository. It was founded around 1999, and it's both a tool and a distribution system. It's designed for PHP authors to take their PHP code, package it up in a neat little package, list the dependencies for it, and distribute it on pair channels, as they were called, or still are called technically. It's still operational, but hey, I think most of you have probably heard of Composer by now, which basically took this concept and made it more modern, more friendly, and is frankly, I think, one of the best dependency manager tools that I know in all the languages and so on. So with the introduction of Composer, which was brilliant, as you might have guessed, I quite like Composer. I'm sure we all do. It's been superseded, right? So pair is very rarely used now. I don't really see it much in the wild anymore. As you can imagine, pair was written a long time ago. The code is very old now, right? And it's kind of a bit outdated, I suppose you could say. So next up, we have this thing called PECL, right? Many people pronounce it PECL, but apparently it's pronounced pickle. This stands for the PHP Extension Community Library. It's pretty much the same concept as pair. But instead of PHP packages, PECL is concerned with extensions. The PECL tool, in fact, is built on top of pair. It uses the same sort of mechanisms, the same distribution, and so on. And therefore, the code for PECL is also very old. And then we have the PECL.php.net website. This is where extensions go to live, right? So when you make a PECL package, right, you run a command called PECL package, and it produces a zip file, and you take this zip file, you upload it to, we need an account first, you log into your account on PECL.php.net, you upload this zip file, and then it's magically available for everyone to use. It used to have quite a neat Windows integration as well, where when you upload your package zip, a Windows build server would come along, look for config.w32, which is like config M4 that we saw in Sarah's talk, but it has the definitions for Windows. And I think it's actually like JavaScript-y stuff, isn't it? So it's interesting. Unfortunately, the Windows PECL build machine died in 2022 for various reasons. And a couple of people at the PHP Foundation, Derek and Shivam, have been working on getting these available again, because obviously it's important stuff, right? People do run PHP on Windows, and it's well supported. So, you know, I think we're almost there with getting it working again. It works, but it's not automated yet. So yeah, nearly there. There's like GitHub Actions available for this stuff, which makes it a little easier. The PECL site is obviously an additional maintenance burden as well. And Derek obviously has to spend time maintaining this stuff. When we already have something that is perfectly usable, like Packagist, for instance. So our goals, therefore, with Pi, or we just called it New PECL Tool at the time, because we didn't have a name. You know, these tools and websites and so on written so long ago, they suffer from maintainability issues, code rot, and things like that. The dependency resolution is not as good as Composer. So we have these goals, like we want a new simplified installer that doesn't use pair anymore. We want it written with more modern practices to encourage contributions. You know, people familiar with how Composer works should, in theory, just be able to dive right in and mostly understand what's going on in Pi as well. And of course, we want improved dependency resolution and so on. And actually, one of the original goals was like signature verification for releases as well. So we also had some non-goals, like things we didn't necessarily want to cover, at least initially. Like Linux OS X binary distribution, for example, is a whole can of worms. There's far too many different platforms, dependencies, and combinations of things that make distributing like the packaged extension quite difficult. Not necessarily impossible, just very difficult. Windows, we didn't necessarily want to distribute the source code for Windows extensions because there's a whole load of things you have to install to actually get this stuff set up. Not necessarily everyone might have VC, you know, Visual Studio Code and so on set up. You know, and you've got to have compilers and all that kind of stuff set up. So that's a bit of a logistical nightmare as well. We also didn't want to write and maintain a package registry. We want to hopefully get rid of that eventually one day. And we didn't necessarily want to handle dependency installation. For example, the iMagick extension requires ImageMagick library. And it seems logical to say, oh, okay, I want this library to be installed. But then, well, the way you do it on Debian is different from the way you do it on Fedora, and it's different from the way you do it on Alpine, and all this kind of stuff. So it gets a bit complicated quite quickly. Also, we didn't necessarily, at least initially, want to cover installing extensions per project, but we'll come back to that bit later. So, a bit of a timeline of when this has happened. In October 2023-ish, the design begins with this. Derek Rethans lays out the initial plans, and kind of puts together this list of what we want to do, what we want to don't do, what we don't want to do, sorry. And shortly after this, Roman reached out to ask about me joining the PHP Foundation. I applied to be a developer there because I have an interest in this stuff. And yeah, Roman reached out, and I joined the PHP Foundation in January 2024. And very quickly, on the 11th of January, we took a meeting with a whole bunch of people. We discussed the goals and how this is going to work and who's going to do the work, and so on. Nils and Jordi offered the use of the packagist infrastructure and said, yeah, let's just stick this stuff up there. Yeah, then we continued planning a bit more, because obviously we don't just start writing code blindly. But yeah, then we started prototyping this stuff back in February 2024. The initial goal was just getting extension downloaded, built, and installed, right? So there's been various iterations and improvements and so on. Initial feedback was great. People were like, oh, this doesn't work, or this works, and so on. In reality, like 6 months was spent picking a name for the project. No, I'm joking. Everyone knows that there's two hard problems in programming: cache invalidation, naming things, and off-by-one errors. So yeah, the remaining 2 months were the actual development work. So anyway, and eventually in October 2024, we released the first functional PyTool. It featured download, build, and install commands, a show command, an info command. We'll have a look at those, what they all do. And we had some very basic dependency resolution and integration with Composer. It wasn't fully complete yet. And a CI pipeline to build a FAR file, a PHP archive, which if you use Composer, you've used a FAR unknowingly. And that's how we're going to distribute it. And of course, some basic documentation, because we'll all be writing documentation, right? So November 2024, I took on the task to rework it to use Composer internals a lot more. It wasn't as straightforward as I expected it to be, but it now works. Lots of discussions with Jordi and Nils, like, hey, this thing doesn't work. And they're like, you're doing stupid things. Stop doing stupid things, James. So anyway, we got there in the end. So it was more or less completely overhauled, like moved everything inside bits of Composer, or like wrapped up in Composer methods and things like that. It simplified a huge amount of code though, right? It allows us to use a lot of Composer's existing mechanisms and leverage those, so we didn't have to do it, right? Like install plugins, we can have metadata for installations of packages, obviously great dependency resolution, downloading from lots of various VCS repositories and so on, like that, we get that support out of the box, and install statistics as well. Like you can see now on Packagist where you have extensions, they have install stats, which, that's great. You can see how much your package is being used. So since then, we've had loads of iterations and improvements. Version 2, if you like, or 0.2.0, had like this full integration with Composer. It had parallel make jobs, because when you make things, you want to use all of your cores, because otherwise you'll be sitting there waiting forever, especially with larger things, like PHP itself, incidentally. The third version had automatic setup of PHP ini entries. It had GitHub attestation, build provenance stuff added in. The version 4 had PyShow with metadata about like what Pi knows about these extensions. Version 5 had a vendor cleanup after we run, because we noticed that extensions were just getting built and all the stuff was getting left behind, and that can be quite large in some cases. So version 6 had repository management. Again, we'll look into this stuff in a bit more detail in a bit. Version 7 had Pi uninstall, and supports also prepackaged source code archives that MongoDB uses now. Bug fixes for ini permissions, Windows reinstall and installs and so on. And again, we'll look into that. That's fun. That's an interesting one. Version 9, these are cool new features that we weren't originally planning. but we're at the point where we can start adding stuff that makes our lives easier as developers when we want to install things. So version 9 introduced PyInstall with no other parameters. When you run it in a PHP project, it will look at your composer JSON and then it will check if the extensions are there and so on. But we'll have a look at that in a bit. And similarly, PyInstall, if you're in a Py project or a PHP extension, if you like, it will then install that as well, as long as it has a composer JSON. So, how does this stuff work? Well, ultimately, the way to install an extension is phpeyes, configure, make, and make an install. Okay? So that's basically what Py does. It's just wrapped up in lots of stuff. So what's the point of Py? Can't people just run those commands? Well, yeah, you can, of course. But we want to make this easier, right? And you know, more intuitive, and you don't necessarily have to know this and how it all works under the hood. So let's have a look at the basic py install package command. The key here is how we integrate with Packagist and Composer. And the basic links to Composer and Packagist makes this work in quite a very familiar way, right? An important thing to note is that extensions are per PHP installation, right? So that means everything in Py has to be scoped to what we've called a target PHP installation. So Py will use the PHP that invoked Py by default if you don't specify anything, but you can also specify with PHP config or with PHP path on Windows. Then it will use that PHP install instead. So how does an extension maintainer add support for Py? Well, it's actually fairly straightforward. Step 1, you add a composer JSON. So you create the composer JSON, and the type must be set to PHP ext, or if you're writing a Zend extension, which is slightly different in the way they work, you would put PHP ext Zend. They're not as common these days. I think even Xdebug changed to just PHP ext. No? Oh, that never happened. Okay, I imagined that. I'm imagining things like usual. You may specify supported PHP versions in a way that's very familiar. You just say, well, I support these PHP versions greater than 7.4 or you know, anything Semver compatible with PHP 8, for example. And then there's this new, it's an optional section, but the PHP ext section, it helps you define extra stuff that you might need to build an extension. Sometimes the extension name might be needed to be specified here. And in fact, for my example that I use for all the tests and making sure this works, it does need this. So if you don't specify the extension name, it will use the second part of the package name. So for example here, it would use example py extension, example hyphen py hyphen extension. But hyphens are not allowed in extension names, so it's not valid. So it will throw an error if you don't specify the extension name, and underscores is fine. So we must specify PHP ext extension name, and then the name of the extension in this case. For most of the part, like for example Xdebug, the package name is xdebug/xdebug, and so we determine the extension name is just called Xdebug, and that's a valid extension name, so it doesn't need to be specified there. Configure options may be specified, and that helps people using Py to affect the build process. You can, as an extension maintainer, you can have like different paths to different libraries and so on, like with whatever the library is and so on. So you can specify those in your config.m4 file, and then you mirror them as well in this composer JSON configure options setting, and then that will carry those through down to whoever's trying to install the extension with Py. So there's some other fields such as priority, support, ZTS and NTS, build path, download URL methods, and a few other things that aren't needed quite as commonly. They're all documented though, so you know, if you find something that's not working, check the docs, and or you know, reach out for help, and we can always help. Maybe one of those options will help you get this your extension working. So once you've got that and you've checked it out, you commit your composer JSON, make sure it exists in the default branch, of course, and you submit it to Packagist. Just like any other PHP package, if you've ever done that, it's just you put your URL in, and it will be like, oh yeah, I found a composer JSON, and it makes your package available. Before you submit it, you can test it by installing your extension with a local path or VCS repository type, and I'll show you how to do that shortly. So there is also step 3 if you want to support Windows with your Pi extension. You would first up need a CI job that pre-builds the DLLs. So I mentioned earlier that the non-goals, we didn't want to distribute source code for Windows, but we do want to distribute source code for Linux, OS X, and so on. So it's completely the opposite way around for each platform. But thankfully, Shivam Mathur has made a GitHub action which builds your PHP extension for Windows. So it generates the DLL and zip file and so on that you might need. And it uploads it to your GitHub release. When you make a release, you tag and release it on GitHub. It will upload that zip file there. And at the moment, it's GitHub only. But we're looking at adding support for GitLab and Bitbucket eventually as well. OK, so what's actually going on when we do Pi install? Extensions that Pi manages are actually very similar to a typical composer project, right? So on your end user system, like the person using Pi rather than being an extension maintainer now, we have a pi.json, which is kind of like composer.json. In fact, it is actually a composer.json. We just used a different name, and a vendor directory. But because Pi is scoped to a target PHP, right, not a project, we have a Pi home per PHP. And so if you look, if you use verbose mode in most commands in Pi, it will tell you your Pi JSON that it's using. And you'll see that the name of the path it'll be in your home directory, config.py or something like that, and then it'll be PHP like 8.4 underscore and then some hash. Now the hash is information that's built up about the target PHP install. For example, whether it's thread safe or not thread safe. If it was built on Windows, it would have like the VC compiler version that it was used, what architecture is, a few other things about the PHP install so that we can keep the information all separate. So it's just per target PHP. So knowing this, the first part of Pi install package is to look for a compatible version selector for the given requirement that you've given it. So you can omit the version. You can just be like Pi install whatever, and it will look for the latest compatible version. Or you can specify different version restrictions. And the format is pretty much mostly the same as what you'd use in Composer. So it should be quite familiar. This step checks a couple of things. One, it checks the package exists first. 2, it checks that the package is compatible with your PHP version that you're running, which PECL never really did. So you could be like, oh, this doesn't work properly. Encountered that a few times. And 3, that the package is available for your selected stability. So this is, again, is not something that PECL really had. It kind of did. But you can specify at stability in a way that you've possibly done in Composer.json or Composer packages that you require, sorry. So you can have like at dev, like star at dev, which we'll see in a demo later. Once we've found a package, and if you didn't ask for a specific version, it will determine the recommended version to put into PyJSON, which is kind of like when you run composer require whatever the package. It's mostly the same process that's going on, so it should be very familiar when you actually run this stuff. So the next part down is to leverage Composer to do the dependency resolution and download, because we don't necessarily want to do all that stuff because it's writing all the same stuff all over again. So we make Composer do it. In practice, this part was more or less the same as downloading any regular PHP package. So remember, each PHP install has its own PyJSON and vendor directory. So actually what happens is it downloads the source code or the zip archive for Windows into a vendor directory. Just to note though, like it does go slightly differently sometimes. So Pi has different ways of downloading from different URLs. Whereas Composer will expect certain things to work in certain ways, like it knows how to find a GitHub zip file, or do a Git clone, or find things on GitLab and so on. Well, we've had to add some more ways of downloading things. So for Windows, as I said, we want pre-compiled zip file with a DLL and maybe some other stuff. And also, sometimes extensions can pre-package their source code. So I mentioned MongoDB. They use Git submodules for some dependencies that they have, which is all well and good. But when you download that using GitHub's zip downloader using the API, you will get no .git directory, but you'll get the Git submodules file. So you can't actually do Git submodules in it to get those dependencies because it doesn't know which reference you've got. So the way they've solved this before when they're using PECL is, well, they have this pre-packaged source code, right? Because that's what PECL is. You package up the source code and send it off to pecl.php.net website. So we're like, well, we can leverage this because you already have all the code that you need with all the Git submodules initialized with the right references and so on. So maybe let's use that. And the other option was to just use Git, but one that introduces an additional dependency. Your system that you're using Pi on has to have Git. And it's probably going to be a bit slower as well because you've then got to do a Git submodule in it if you have Git submodules. So yeah, we went with the simpler option here, I think. And so MongoDB, if you look at their Composer JSON, it will have this download URL method stanza in the PHP ext part of their Composer JSON. And that will basically tell Pi, don't use the normal source download URL that you would use in Composer. Use this one instead. And it's a predetermined URL, so you have to obey the specifications on that when you upload your zip file. We also support those prepackaged zip files in the old PECL naming scheme, because that actually means that all of the older versions of MongoDB will continue in theory, I think, working with Pi. I haven't actually tried it personally, but that just allows a little bit of backwards compatibility and slightly easier onboarding mechanism. So the way Pi does this is it has a listener that tells Composer, hey, I want to listen for a particular event, and we just hook into that and we say, okay, if we need to change the URL to download from, just do it, and we just hack away at the Composer bits and change the URL. So that works. And then the rest of the Pi process is like the next step is actually implemented as a Composer plugin, a Composer installer plugin. And that particular part will do the PHPIs, configure, make and make install, and so on. And then we have that cleanup at the end to delete the vendor directory because we don't want to leave a load of stuff lying around. So I mentioned briefly you can target a different PHP install. So you can use with PHP config on Linux, OS X, and basically anything that's not Windows. And so you pass the path to what's called php-config. And that's a tool that basically tells you a load of information about your PHP installation. It tells you things like extension directories, ini files, configure options that we used, and all this kind of stuff. Or you can use with PHP path on Windows, because Windows doesn't have PHP config, because yay, consistency. And Pi makes some reasonable assumptions about how a Windows PHP installation is set up, because usually it's like one directory and then you've got like ext and a load of other folders and so on. And that's fairly standard, unless you've started moving everything around, in which case you're kind of on your own anyway. But the big benefit of these options is, like, one thing I haven't said so far is Pi is written with PHP 8.1 as a requirement. Like, so we're using PHP 8.1 features and so on. We wanted to introduce it with the latest supported PHP version, sorry, the oldest supported PHP version at the time. But you can still use Pi to install extensions on much older versions of PHP. So you would use the with PHP config. So you would have, for example, PHP 8.4 or something running, and you run Pi with that, but then you target it to your old like PHP 7.4 or 5 or whatever, 4 maybe, I don't know. So it is theoretically possible. You just have to have kind of 2 PHP installs side by side. Yeah, so let's have a look at some of the Pi features. This photo of a Pi. Thankfully, thanks to Rob for the photo. Rob has a great Flickr collection. What did you describe it as? Old man's Instagram. But he has a great selection of photos, and when I do talks, rather than using AIs and stuff, I say, hey, Rob, can I use your photos? And he had a photo of a Pi, and that fits in nicely. So, little story about that one. So we have a nightly build. As you might have guessed, Pi is in very active development at the moment, so things can change frequently. We can add new things. I try and release fairly frequently anyway. You know, if someone reports a bug, I'll try and fix that as quickly as possible and so on, but I wouldn't necessarily release immediately unless it's something really, really critical that's broken everything. Hopefully that doesn't happen. We do have tests. Yeah, so new features being added, bugs being fixed, and so on. So the nightly will always have the latest changes that have been merged, at least. It's linked to on the Pi GitHub page, so you can download it from there. If you want the regular stable, it's not quite stable yet, but we'll get there. If you want the latest release, that's on the GitHub releases page. So you just go to the latest release and download pi.far, and that's it. So we have Pi Show. Pi Show is a way of listing all of your loaded Pi extensions. If you specify the --all flag, it will also display all of the extensions in your target PHP install that, even if they don't have Pi metadata. So those ones, Pi is like, well, I don't really know what I'm doing with that one. But Pi, when you do a Pi install, we store a load of metadata about it, like the hash of the .so file that we installed, where we installed it to, what the target PHP was, and all this kind of stuff. So if it ever changes, and like the hash, for example, doesn't match what Pi thought it was, you'll see like a yellow warning triangle here instead of a green tick. And that just means something that's changed. And in theory, Pi is not sure what's going on, right? Something's gotten out of sync. Hopefully that never happens, but if it does, you know, maybe you used PECL install on top of it with a newer or different version, and then Pi is like, well, this is not the version I thought it was. So it's theoretically possible. Sudo was interesting. In general, in lots of playing around with it and running, I've run Pi so many times now, as you might have guessed, pretty much every day, I think. I would recommend that you don't run Pi as root. Just because if you run it with root, you're actually running as a different user, so it has a different set of Pi metadata because it's got a different home directory. So it's not ideal, so it might get confused. However, quite often, we will need to become root. For example, when we do make install, that will be copying a shared object to usually a folder that's owned by root, right? So we have to write a load of wrappers, essentially, for all of these things that may require root. We wrap it in this script that tries to do sudo for stuff. So like creating a file, writing content to a file, deleting files, and so on. And so we attempt to use it, like if sudo is there, like in your path, it will use it. If not, it will kind of say, oh, I can't do this, but this particular thing. And Windows is an interesting one as well. It's not necessarily related strictly to sudo, but because sudo is not really a thing unless you're using WSL, perhaps. But Windows, you can't delete things that are being used, right? So for example, when you upgrade or delete an existing extension, well, especially if you're running running Pi using the same PHP that you're trying to uninstall an extension from, well, this is going to be needed because you're running Pi with the PHP with the extension loaded, and if you want to upgrade that extension, it's got to replace that extension. But you can't do that. Windows will be like, nope, no thank you. So after lots of head desking and how do I do this and lots of searching and so on, I found this technique to basically just move the file out the way somewhere else and then put the new extension in place. So it's not particularly the cleanest solution. So what we do is we take the current extension, we move it into the temp directory, and then put the new extension in its place. So the hope is that later on it will get cleaned up automatically when the temp directory gets cleaned out, some point in the future. So yeah, it's not necessarily the best, but it does work, at least for now. And the next time you invoke PHP or restart Apache or whatever, however you're running it, it will pick up that new DLL, and everything will be shiny in the world, except you've got this old DLL in your temp directory. But let's ignore that part, shall we? So another thing I mentioned is using all your CPU cores when you compile things. We use a package from Theo Fridry to count the number of CPU cores, because that's never simple, is it? So when you run make, make will usually just use one core. So you use make -jn to use however many cores you specify. So we use that library to pass that number to make by default. But if you want to override it for whatever reason, like maybe it didn't detect the right number of cores, you can use pi install -j in exactly the same way as you'd be used to when you're running make. So that's there. Adding the extension to PHP INI as well. So normally when you install an extension, you want to put like extension equals and then the name of the extension. And you might be like, well, how hard could that be? You're just adding a line to an INI file, right? Well, yes. But as is the real world, right? Everything does it slightly differently. So like the deb.suri.org repos has this tool called PHP enmod to enable PHP extensions. And it also has split SAPI configs. So there'll be an INI directory of Apache SAPI configs and then CLI SAPI configs and so on. So we've got to put it in both places somehow. So that's what this tool does. So Pi will try and detect, does this have PHP enmod? If it does, it will use that to enable the extension. Docker, the PHP images provided by Docker, which people call the official PHP Docker images. They're not made by PHP, by the way. They're actually made by Docker. But yeah, anyway, side quest, that one. That uses a Docker PHP ext enable tool. So if we detect that in the path, we'll use that to enable the extension. And then even PHP itself has two different ways of configuring INI files. When you compile PHP, you can specify an additional PHP INI directory. So we will look at PHP info and say, has PHP been compiled with this additional directive? If we do, we will make a file called like your extension, it'll be a number, like the priority. I mentioned that earlier in configure options, it will use that. And then the name of your extension, .ini, and then we'll put in the the directive to enable your extension. So extension equals whatever it is called, or Zend extension, whatever it's called, if it's a Zend extension. And finally, if not, we'll just use the loaded PHP ini to add it. In theory, you can run PHP without a PHP ini as well. So in that case, we just give up, because I've run out of ideas. It's not foolproof. It may not be fully comprehensive, but it covers like maybe the 80% use case. So it should work in most cases, I think. If anyone encounters PHP INI not being added automatically or something, let me know, because we might be able to add support for it. You know, if lots of people use it, then yeah, let's do it. I mentioned we publish build provenance records for Pi. Quite often for open source packages, like we've done GPG signatures in the past, which are only as good as the build system you're building on anyway, really. But GitHub and a load of other organizations have started doing this attestation stuff, OIDC, I think it's called, something like that. And if you have a pi.far, whether it's a nightly or any pi.far, you can run gh, which is the GitHub command line tool, gh attestation verify. You give it owner PHP because you want it to be owned by the PHP organization on GitHub, and give it the name of the file. And if it's genuinely from the PHP GitHub organization, it will give you this verification succeeded tick, and everyone will be happy. So this is cool. We use this, therefore, so you can say, yes, this came from PHP, and it's not some nefarious bad actor giving you a naughty pie. A stale pie? I don't know. Anyway. So we have a self-update command. This was interesting, and I think as only recently I've ironed out all the bugs with it. Hopefully there's no more bugs with it, because it's kind of difficult to upgrade if it doesn't work. So it's kind of a catch-22 there. But when you do upgrade, we use gh attestation verify. If gh is in the path, it will try and verify that. Or if you've got the OpenSSL extension loaded, it will try and do sort of a basic validation. So we make sure that the attestation certificate is signed by a trusted root. We verify the attestation OID claims, like the issuer, what repo it came from, and so on. We check the payload digest matches what we expect it to be. And then we check the actual signature of that, the archive, the far file. Big thanks to Tim Dusterhus, I probably butchers his name, for helping me with this and making sure that I'm doing it right and not missing out important steps. We can manage repositories, like with Composer, repos, VCS, and paths, and so on. So you can add a Composer repository, which is basically packagist, private packagist, Satist, things like that, which is great for organizations that have private extensions to build, perhaps. I don't know if there's many in the world, but you can also turn on and off packagist.org itself, which is what they recommend when you're using private packagist anyway. You can also add a VCS repo directly. Like if you want to test it before submitting it to packagist.org, you can do that, and also from a local path. There are some weird behavior differences. For example, if you're using a local path and you're trying to install MongoDB, it probably won't work because it's going to be trying to override that download URL. So we haven't got a great solution for that. You may get weird behavior, or it might say, oh, this package doesn't exist, or can't download this file, or something. So, but let us know if you have issues. Make a GitHub issue. Then let us know what you're trying to do, and we'll see if we can help, and just give us feedback on that. The point of Pi is to install things, but hey, sometimes you might want to uninstall an extension. So assuming the Pi metadata all matches up, we'll remove the .so and comments in the ini entry, and so on. This is quite a fresh off the press thing. Pi install in a PHP project. So you go into your PHP project, you type pi install, it will look at your Composer JSON, figure out all the extensions it needs, and it will then go through and interactively prompt you, hey, do you want to install this one, or whatever. Similarly, we have Pi install in a Pi project. So if you go into the Pi project directory, the PHP extension, right, and you just run Pi install, it will detect that it's an extension, and it will just install it. And it actually does that by temporarily adding a local file path repository, runs Pi install, and then removes that local file path. And that's pretty much it. You can use Pi in a Docker file as well. Greg Korber contributed publishing the Docker file with the Pi binary, which just has Pi far. There's nothing else in it. There's no dependencies or anything. So the actual platform is still your responsibility. Quite a common question I get is about Rust, C++ support, and so on. Theoretically, yes, you can run any other language as long as it has PHPI's configure, make, and make install available, then it's fine. It should work. So what's in the future? Well, we want to get to a stable release, obviously. we want to get as much feedback as possible, reduce any onboarding issues, handle bug reports, and so on. We want to sort of have it officially adopted as a replacement for PECL. We believe that it will further increase confidence in the tool and say, oh yeah, this is not just something that's work in progress or something. And eventually, hopefully, end of life PECL and PHP, PECL.php.net. Don't panic, we're not doing it like tomorrow or anything. There's still time. There'll be as much sort of publication about it as possible when that comes, when that time comes. And I'm going to start trying to go around to as many PECL packages that don't already have Pi support as possible and give guidance to those extension maintainers, if they're still maintained, of course. So PECL will continue working for now, but we want to encourage people to make it installable with Pi. Other commands like list upgrades I want to do, list all the available extensions and upgrade them according to the version restriction you put in initially. And of course, then Pi upgrade to upgrade those all. I also want to list all the dependencies when you run Pi info. And an often asked question I get is, well, could Pi install those dependencies? In theory, yes. But the number of different platforms, package managers, and all this kind of stuff makes it a difficult problem to solve. But it's something I want to look into. Project scoped extensions is interesting. This is another one that's asked after a lot, but in practice, we need to change PHP itself to make this actually work. So, yeah, there's some suggestions, ideas floating around, but we'll look into it at some point. Theoretically possible, just we need to make sure we do it nicely in a way that works. So I'll give you a very quick demo. Hopefully my internet will work. Oh, it's not called example, it's called demo. PHP project. Okay. So we can see this is our PHP project that we have. This is a great project. We depend on curl, example Pi extension, and in dev we depend on xdebug. So if we run our example PHP script that I have, it just says whether the extension is loaded or not. At the moment it's no. So, okay, let's use Pi. So we just run Pi install. This is where the internet fails me. Ah, internet. Oh, it worked. There we go. So it does a search for example Pi extension here, and I will pick my own one, not the fork from someone else. And it will go ahead and download that, and the internet is being super fast. So we'll just sit and wait for a while, which it finds it, but yeah, it's being very slow. It's not normally this slow, even on my poor home internet connection. So okay, let's do this faster, because, oh, there we go. It's going, it's going. There we go. Okay, so I'm not going to install xdebug for now, because otherwise that'll take forever. So now if we do Pi show, now we can see that we've installed our extension. That's great. And now if we run our example script, it will say that the extension is loaded. Woo! It worked. So yeah. There's a couple of other things I wanted to show you, but I'm running out of time, so I'm going to have to call the demo there. Okay, so lastly, what do you want to see in Pi? I'm always open to ideas, suggestions, and so on. As I said, like my main goal for this is to make installing extensions super easy. We're aware of some things that we need attention, like I mentioned. Yeah, big thanks also to PHP Foundation, Sovereign Tech Agency for supporting this project. So yeah, thank you very much, folks.